Hello everyone, welcome to our AI engineering crash course. This is the first course of the third module of our complete tutorial. So in this first course, we'll talk about embeddings. In the past module, we talk about AI and AI engineering, we talk about prompting, and we gave a complete overview of many providers, including frameworks also, and hosting platforms. In this module, we'll go through vector databases, retrieval augmented generation, and globally how to use external source of documents into your application. So in this first part, we'll talk about embeddings. And in the second part, we'll talk about vector database and semantic search. And then in the upcoming part, we'll talk about RAG, chunking text and error handling, libraries, which are actually frameworks that we'll be using, and we'll build a complete project together. Let's get started. So we first need to start by talking about embedding, okay? And to talk about embedding, we need to understand why it has been created at the beginning, okay? So let's first just say you have a simple problem, okay? You want to search for a specific thing in a really long document. Let's say what you're looking for is actually a new subscriber to the channel, okay? Let's say you have a text like this and you would like to see if subscriber is in this text. How do? You do something like this, right? So like this. You try to match subscriber to every single word here. You try to match subscriber to A. You do like a word-to-word comparison. And when you reach this word here, you'll see that as everything's matching, right? Every single character is matching the subscriber here. So you can say, oh, I found subscriber in your text, right? So what happens if this subscriber here is written that way? Okay. Subscriber like this. It will actually fail, which will limit your capacity as maybe a search engine, maybe a local search engine or a global search engine to give response that contain errors. So many algorithms has been created to actually solve this problem, which help calculate the level of similarity between the text that you're trying to compare to the actual text. So it will say, okay, you can use the Levenstein distance, for example, to say to quit from this to this, you need like to this subscriber to this subscriber, you need just to add one S, so they are pretty close. So maybe you wanted to say subscriber. So what if you say a new member of my YouTube channel now, of YouTube? Now it's completely different. It's kind of the same meaning. Subscriber is a member of your YouTube channel, but the search will fail. Why? Because member of YouTube channel is not written the same way as subscriber. So this is a really big problem, and embeddings is coming to solve that, right? Embedding is a really generic concept that has been implemented in so many tools out there. For example, Google image search can be implemented using embedding, and I will explain how later. Same for Google itself. You can build a simple search engine for your local website or for your local database of documents using embeddings. Embeddings is a really powerful concept. So let me first start by explaining what embedding are supposed to be. So let's say you have a text. Let me just draw a quick line here. Okay. Let's say you have a text like this: Queen, King, Dog, Woman, and Man. Okay. How do you do to actually represent the semantic of this text? They have different way of being written, but if you want to get the meaning of the text, you need to actually transform them into a numerical representation, plot them in some kind of space, and make sure that the distance between different items that are close in terms of meaning is smaller than items that are far in terms of meaning. Okay, so let me just draw an example here. Let's say we have this, this space here, like 2D space, like this. Okay. If you have a point A here and a point B here, and maybe point C here. If you plot a lot of words in these different places, you will be able to know that this is pretty not that close to this word compared to this and this, right? Okay. So that's the same concept. If you put queen here, if you take this queen and you put it here, no, let's say dog here. Sorry. Dog here, king here, and queen here. You will see that dog is far in terms of meaning to king and queen. Okay, so the concept of embedding is to create a model that will be able to get some text and infer the semantic meaning from this text and be able to generate or create a vector of numbers in some kind of space that mimic this semantic, okay? Which means in this vector, you will have words that are related, that are pretty close. So you can actually do a simple distance in terms of member of YouTube to subscriber. This is actually sentence embedding. And see that, okay, member of YouTube in my space is kind of close to subscriber. So maybe the person is trying to search for subscriber. So that's the whole concept of embedding. Okay, and it's applied to many things. It can be applied to images. So if you extract some feature from an image and you are able to have them in a space where image with similar features are close enough, you can do a Google search by image. Because when someone will give an image, you extract the features from that image in some kind of numerical representation, and you'll see that, oh, this image that the person gave is quite close to this other image, so I can show it out. Okay, the whole concept of embedding is to actually just have in some kind of space multiple words, so the dimension is really high. It's not just a 2D space. Multiple words, 1, 2, 3, 4, 5, 6. These are actually words. And to make sure that these words, let me put some right, these words are close enough in terms of semantic. So when you calculate the distance between them, it's small. The distance between this and this, this and this, it's actually small. So you can infer that they are semantically close. Okay. Yes. And in terms of semantic models, you have a lot of providers that build really good models. OpenAI has an embedding model, Google, Anthropic, and you can have Hugging Face embedding as well, if I'm not wrong. You have many embeddings models out there. You can just go on Hugging Face, find some embedding in there and use it in your app. And right away, even without any LLM, you can actually make some really good app like semantic search on text, for example, or just semantic search on images. So you just need to find an image embedding that's trained with a lot of images, okay? And that's accurate enough to have the right feature for different range of images. So that's it. Embeddings just means having text represented as a vector. And this vector is in a space where words with related meaning are close. So the distance between these words are pretty small. Okay, so with that said, this is the theory part of this. Now, the practical part of it is how do we use it with our retrieval augmented generation? As I mentioned in the last module, we went through, we built a simple app that get a PDF and try to answer some question based on that PDF. And what we were doing is feeding the whole content of the text to the AI. So what if when the user asks for something pretty specific, we are able to go through that exact part of the PDF, extract exactly that part, and give it to the AI so the AI can use it as context. That's pretty interesting, right? Instead of feeding a lot of token and burning money, you can just feed a small part of your PDF to the AI, and the AI will be able to get to answer the question correctly only based on the information you feed it, you gift to it. Okay, so that's interest. That's what we will be doing in the next part, which is about providers like vector data, vector store, and semantic search. And I will show you how to use these concepts clearly into your app using LangChain. So thank you for watching, and see you in the next one.